myself Ragni. I hope all of you are good and healthy and doing well. So I am going to solve CSIR NET 26 November and 2020 question paper. So I am going to solve question number first, and it is a part B question, so let us read what is our question and then try to solve. So what is given here? Let A be a 2 by 2 real matrix. अच्छा, यहाँ पे मैट्रिक्स कैसी हमारी रियल है, विद डिटर्मिनेंट 1 दिया है एंड ट्रेस क्या दिया हुआ है, 3 दिया हुआ है. सो हियर वी हैव टू व्हाट देन द वैल्यू ऑफ द ट्रेस ऑफ ए स्क्वायर. सो हमें यहाँ पे बताना है कि ट्रेस ए स्क्वायर का ट्रेस क्या आएगा. सो वी हैव टू फाइंड दिस. सो व्हाई नॉट पॉज वीडियो एंड ट्राई. Okay, so let us solve. So what is given here? What is given? Given here trace क्या दिया हुआ है, trace of a equal to दिया हुआ है 3 and determinant क्या दिया हुआ है, determinant of a दिया हुआ है 1. ठीक है. So क्या करते हैं, suppose lambda 1 and lambda 2 are two eigen value. ठीक है, R2 eigen value. Okay, so if lambda and lambda 2 are 2 eigen value, then lambda 1 plus lambda 2 equal to what? Trace of A, which is given 3, and another thing, what? Lambda 1 into lambda 2 equal to what? 1. Okay, now all we know what? We know a plus b का whole square equal to a square plus b square plus 2ab. Okay, so in our case lambda 1 plus lambda 2 का whole square equal to lambda 1 square plus lambda 2 square into lambda 1 into lambda 2. Okay, see, it is nothing but your trace of a का whole square, and it is nothing but what? Trace of a square. Okay, how? Think about. Okay, and 2 into determinant of a. See, if lambda 1 and lambda 2 are eigenvalue of a, then as a square is what? A square is a polynomial of a, na? So here the eigenvector, same eigenvector will work. So that is why we will write then eigenvalue for matrix A square will be what? Lambda 1 square and lambda 2 square. Okay, that is why this. Think about this little bit, you will get it. Okay, see, so what we get here, we will get this thing, and now this thing implies what? What is your trace here? Your trace is what? This thing, see, and determinant is this. So we will put the value, just put and try to little bit solve. So 9 square equal to lambda 1 means कि ये आपका आ गया trace a का square, and plus 2 into 1, which implies that trace of a square is equal to 7. Okay, so it is your correct answer. So let us see which option correct, huh? So which one correct? Option 4, right? So option 4 correct. Okay, so let us try to do another question. So here I am trying to solve algebra question. Algebra question means the linear plus abstract. Okay, so I will try to solve a linear algebra plus abstract algebra. So see, question number 4. So what is our question number 4? So here let A and B be 2 by 2 matrices, then which of the following is true. तो हमें बताना है इनमें से कौन सा ट्रू, क्योंकि ये पार्ट बी का है, पार्ट बी के क्वेश्चन है तो सिर्फ एक ही करेक्ट है. ओके, सो हमें देखना है कि इनमें से कौन सा ऑप्शन करेक्ट है. सी, यू कैन डू दिस क्वेश्चन बाय यूजिंग आई मीन डिस्कार्ड करके आप सॉल्व कर सकते हो. टेक ए इक्वल टू बी, लाइक दैट थिंग्स, एंड आल्सो यू कैन सॉल्व इन अनदर वे like I am going to solve, and it is also, I mean, little bit good way to solve. So let us try to solve. So first of all, we will let what we will take okay, so I am going to solve here, huh? So क्या करो आप, let कर लो, let A and B be 2 by 2 matrices. Okay, two matrices and suppose क्या suppose कर लो, suppose A has eigen value lambda 1 and lambda 2 and B has, because it 2 by 2 so टू डिस्टिंक्ट हो सकते हैं, एट मोस्ट टू डिस्टिंक्ट आइगन वैल्यू हो सकते हैं. सो बी हैज़ आइगन वैल्यू μ1 and μ2. Okay, so okay, suppose in particular, we will take in particular case. Okay, in particular, if B is polynomial matrix of A. Okay, if B is a polynomial of matrix A, then same eigen vector will work corresponding to eigenvalues. Okay, eigenvalues lambda 1, lambda 2. Okay, and also for B. So here eigenvector same will work because यहाँ पे जो μ1 and μ2 होगा वो lambda 1 lambda 2 का multiple power something product होगा. So in that case, so now if lambda 1 and lambda 2 are eigenvalue of A and μ1 and μ2 are eigenvalue of B, then lambda 1 plus μ1 and lambda 2 plus μ2 are eigenvalue of A plus B. Okay, fine. So here A plus B का eigenvalue ये दोनों हो जाएगा and lambda 1 minus lambda 2 μ1. Okay, sorry, my mistake. So lambda 1 minus μ1 and lambda 2 minus μ2 are eigenvalue of A minus B. See, it is possible to sum because same eigenvector will work for A and B both, and that is why I am taking particular case. Okay, I hope you are getting it. So I am taking in particular case. So in that particular case we are trying to solve. Now see all these things. Okay. So what here we will get? Here we will get what we get. Okay, so determinant of, we will use as we know determinant nothing but product of eigenvalue, so we will use this thing and then try to solve it. So when you will use this, you will get determinant of A plus B and plus determinant of A minus B, which is equal to what? Which is equal to as you know what is eigenvalue of this thing. So here you will get lambda 1 plus μ1 into lambda 2 into plus μ2 and plus you will get here, you will get what? You will get lambda 1 minus μ1 and lambda 2 minus μ2, and just try to solve it and then try to see what you will get. Okay, so when you solve it, you will get here lambda 1 lambda 2 plus μ1 lambda 2 and plus lambda 1 lambda 2 plus here what you will get here, wait, one more term. Okay, so μ1 μ2 and plus lambda 1 and lambda 2. As you can observe, these two terms in minus. Okay, hope I am doing correct. So you should also try to solve with me that we can get correct. Okay, so plus μ1 μ2, and as you can observe this term are cancel out, and you will get 2 into lambda 1 lambda 2 and plus 2 into μ1 μ2, so which is nothing but 2 into determinant of A plus determinant of 2 into determinant of B. So in particular it is it implies this thing. So now see which option correct. Okay, so this option correct, and as you can see, if it is not imply these option in particular, so how it will be in general true, and that is why your these three options incorrect. So these are incorrect. okay. And also if you want to do quick, you can just skip the this linear process. You can just try to solve from here and just assume lambda 1 lambda 2 eigenvalue of like eigenvalue of A, and mu1 mu 2 is like eigenvalue of B. And then in particular if B is a polynomial matrix of A, then we can then the same eigenvalue will work, and in that particular case we will we can say about the eigenvalue of A plus B and A minus B, and in that case we will get these things and then try to go with this. I think it is very simple method if you will try to solve, okay, and avoid the writing thing. So okay, or also if you want to do quick, just take A equal to B and just try to verify it, okay. Okay, so let us try to do another question. And as I said, I am trying to solve linear algebra plus abstract algebra. So another question, and it is question number 7, okay. In your booklet it is question number 7, maybe you have another booklet. So okay, so which of the following real quadratic form on R2 is a positive definite? Okay, what do you mean by positive definite? Okay, write in comment box, and which definition you know. So let me in comment box. So what I know, if it is positive definite, a real quadratic form, positive definite, if it's if matrix representation of quadratic form have a matrix, okay, all principal diagonals, okay, have okay, all principal minors is greater than 0, then it is a positive definite. In other word, in other way, if all eigenvalue are greater than 0, then it is a positive definite, okay. So what we will do here, let us try to solve, okay. So first of all we will write in a matrix form. So here if you represent quadratic form in matrix form, A, suppose A, then it will be as it is 2 by 2 matrix as R2, okay. So here what you will get, 0 0 and 1 by 2 1 by 2. So one, as you know, row sum, column sum, row sum, each row sum is 1 by 2, so one eigenvalue 1 by 2, another eigenvalue, as we know, trace sum of eigenvalue equal to trace of A. So here as you can see, suppose if lambda 1 and lambda 2 are eigenvalue of your matrix A, then lambda 1 plus lambda 2 equal to 0, and as you know, one eigenvalue is 1 by 2, so plus 1 by 2 lambda 2, which is equal to, which implies that lambda 2 is equal to minus 1 by 2. As you can see, your eigenvalue, each eigenvalue not positive. As you can see, this is negative, less than 0, and it is so it is indefinite, okay. And when we will say indefinite, if one of eigenvalue is positive and another is negative, then we will get indefinite, okay. So as not all eigenvalue positive, so it is not a positive definite. So first option incorrect. Let us see another. So another, what is here 1, a minus 1 by 2 minus 1 by 2, and it is 1. Now see, each row sum is 1 by 2, 1 by 2, so one eigenvalue 1 by 2, and as you know, trace is nothing but sum of eigenvalues, so lambda 1 plus 1 by 2, suppose okay, 1 by 2 is equal to 2, so it implies that lambda 2 is equal to what? It implies lambda 2 is equal to 2 minus 1 by 2, which is equal to 3 by 2. See, now we done, because we get option 2 correct. But if you want to verify, you can check another 2 option same way, and you will get not a positive definite, okay. So I am leaving for you. You will do these 2 options and see whether it is a positive definite, indefinite, and what, semi definite, semi positive definite, semi negative definite, okay. So try to see, and also let us know whether you are going in a more simple way. So if you know, let me in comment box, okay. So let's try to do another question. So question number 8, okay. So what is our question number 8? Let A be a 2 by 2 matrix and such that the set of all its non-zero eigenvalue has exactly R element. Acha, okay. Then which of the following statement is correct? True. तो इनमें से बताना कौन सा true है? अच्छा, just think about, what about the eigenvalue, I mean non-zero eigenvalue. It let A be a n by n matrix such that the set of all non-zero eigenvalue, okay, the set of non-zero eigenvalue, see this thing, has exactly R element, okay, has exactly R element. So what we'll get, why not pause video and try this question, try to think, okay. So let us think about what can we do, okay. See, what is GM here? What is GM here? Okay, GM, as we know, GM of 0 is less than equal to AM of 0, है ना? In general, GM of lambda I is equal to AM of lambda I, right? Correct or not? Correct, na? Okay. So here AM is nothing but what? Yes, right. What? N minus R. Okay. And what is your GM? It is nothing but what? Let me know. Yeah. N minus rank of A. Okay, so what you will get here, less than equal to, and which implies what, minus rank of A is less than equal to minus R, which implies what, एज यू नो साइन चेंज होने पे ये क्या होता है, अपोजिट सिंबल हो जाता है. ओके, सो रैंक ऑफ ए इज ग्रेटर देन इक्वल टू आर. ओके, सो सी विच ऑप्शन यू आर करेक्ट, दिस. ओके, fine. So let us try to do another. Okay, wait, if you are doing this question in another way, and it is interesting and you are enjoying this other way, so let me in comment box. Why not we will enjoy all the question together. Okay, so let me in comment box if you are doing it with another way. Okay, so let us try to do another question, and question number 10. Okay, so what is our question number 10 here? So what is so let A, which is again 2 by 2 matrix. Okay, they are very interested in 2 by 2 matrix, as you can see. Okay, see what is given here. Here the columns are, two columns are given, 3 minus 2, 2 minus 1, then a power 20. We have to calculate this. Okay, we have to find it. Okay, why not pause video and try this question? Okay, so let us try to solve together. So what we will do here? Okay, see, as we know what, as we know, if V is eigenvalue corresponding to eigenvector, okay, corresponding to eigenvalue 1. Why I'm saying eigenvalue is 1, why I said very quick. We know corresponding eigenvector क्या आ जाएगा यहाँ पे, 1/2. यहाँ पे v क्या आ जाएगा, 1 1. ओके, सो यहाँ पे आइगन वेक्टर आ जाएगा करस्पॉन्डिंग आइगन वैल्यू 1 1 1. सी दिस थिंग, a v is equal to 1 into what I am using, lambda into v. Okay, so here you will get what, a into v is equal to lambda into v, and in general a n into v is equal to lambda into lambda n is equal to v into v. So in particular what you will get in particular, a20 into v is equal to okay, 120 into v. So see, okay, so देख लो इनमें से किस में आपको अगर 1 1 मल्टीप्लाई करा दो तो क्या दे देगा, 1 1 ही दे देगा. चेक करो जल्दी से, ये कौन 1 1 देगा. सो 41 minus 40 minus 39 into 1 1. So you will get what, you will get not 1 1, right? It is not equal to 1 1 as verified. And option B में क्या है, ऑप्शन बी में क्या है, अच्छा 41 minus 40 minus 39. If you multiply 1 1, so you will get 1 into 1 1. Check it. Okay, so in B you are getting, so your option B is correct, and also verify option 3 and 4 and you will get not. Okay, you will not get A. Just write here 20 also if you wanted to write. Okay, oh sorry, okay, so check, I am giving you exercise C and D, so verify it whether it is correct or not. As you know, it is a part B question, so it is, so only one option correct, but in part C we have to check all. So you check it and let me know in comment box whether it is correct or not, and let me know also these methods are helpful for you or not. Okay, so that I can improve it and make more video. Okay, so let us try to solve another question. What, question number 11. So what is our question? For a b in R, and let p of xy is equal to a square x1 into x1 into y1 plus a into b x2 y1 plus a into b x1 y2 plus b square and x2 y2. अच्छा, for what value of a b does p R2 cross R2 to R define. Okay, इनर प्रोडक्ट. सो हमें बताना कि इसकी किस वैल्यू के लिए ये इनर प्रोडक्ट होगा. अच्छा जी. Okay, so let me remind what is inner product. So first of all, for inner product we have to check whether it is a positive definite or not, है ना. So to check it is positive definite, what we have to check? We have to check this quadratic form is positive definite or not. So because it comes from R2 by R2, so matrix will be what here, your here matrix will be A square, AB and B square. So we will check whether its principal minors are greater than 0 or not. So as you can see, as you can observe, A square is greater than 0, B square is greater than 0, and determinant is 0. Determinant is greater than 0 or not, we will check it. Okay, so here A B into AB and minus A square B square, we have to check. See, it is 0 greater than 0. Is it true? No. How can it possible 0 is greater than 0? Okay, so for all AB in R, for all AB in R, and see, it is not true. It is not true for any AB in R. Okay, so your option B is correct. For no value of AB, it is correct. Okay, so okay, so let us try to do another way, another question. So okay, as we are solving algebra question means ki linear plus abstract. Okay, so in abstract here number theory, ring theory, group theory. So our first question, which is question number 30, it is from number theory. So let us read and try to think about this question. Okay, so what is our question? Let phi of n be the cardinality of set and A such that 1 is less than equal to A is less than n, and okay, यहाँ पे जो phi of n है वो किसी सेट की कार्डिनलिटी को रिप्रेजेंट करती है, जहाँ पे सेट क्या है आपका, कलेक्शन ऑफ दोज A such that 1. अच्छा, A कहाँ से आ रहा है, कहाँ से आ रहा है A? यस, कहाँ से? n से. ओके, so 1 is less than equal to A is less than equal to n, and such that A comma n is equal to 1, where A comma n does not क्या कर रहा है, डिनोट कर रहा है GCD of A and n. Then which of the following is not true? So we have to find इनमें से कौन सा करेक्ट नहीं है. अच्छा, इनमें से सही कौन सा नहीं है, हमें ये देखना है. ओके, so let us go option by option. So here option first is what? There exists infinitely many n such that phi of n is greater than phi of n plus 1. Okay, why not pause video and try this question, try to think about. Okay, so let us start. So ऑप्शन फर्स्ट क्या दिया हुआ है, कह रहा है कि यहाँ पे एक एग्जिस्ट कर रहा है, क्या एग्जिस्ट कर रहा है, नेचुरल नंबर एग्जिस्ट कर रहा है. ठीक है, सच दैट तो क्या आता है, फाई ऑफ एन जो है वो ग्रेटर देन इक्वल टू फाई ऑफ एन प्लस 1 है. ठीक है, सो ऑप्शन फर्स्ट क्या है आपका, ऑप्शन फर्स्ट क्या है, क्या दिया हुआ है, देयर एग्जिस्ट इनफाइनाइटली मेनी, सॉरी देयर एग्जिस्ट इनफाइनाइटली मेनी. ओके, meaning n such that phi of n is greater than phi of n plus 1. Okay, when you are looking this option, what come in your mind first thing? जब आप इस ऑप्शन को देख रहे हो, सबसे पहले आपके माइंड में कौन सा क्या आ रहा है? ओके, क्या आ रहा है? यस, यू आर राइट. यहाँ पे मान लो कि आपका n जो है वो प्राइम है. क्या है? प्राइम है. ठीक है, अच्छा, प्राइम है तो वी नो प्रॉपर्टी ऑफ आइलर फाई फंक्शन. ओके, सो वी नो फाई ऑफ p इक्वल टू p minus 1. ओके, सी here you will get this, but if it is a prime and then p plus 1 क्या हो जाएगा, ये इवन हो जाएगा. ठीक है, ये क्या आ जाएगा, इवन हो जाएगा. इवन का मतलब क्या, मतलब यू कैन राइट इट लाइक 2 इंटू m. सपोज करो इट इज अगेन ए प्राइम, 2 इंटू m, बिकॉज देयर आर लॉट ऑफ प्राइम्स ना. so when you take phi of this thing and these two are co-primes, means 2 comma m equal to 1, and it is there are infinitely many elements like that. Okay, so in that case what you will get what, phi of 2 which is 1, and phi of m which is always what, yes, less than. Okay, less than phi of p. So here it implies that what, it implies phi of p less than phi of p plus 1. Sorry, okay, phi of p plus 1 is less than phi of p. So there are a lot of, you can see, if you take u 2 3 5 7 and 7 11 30, and see phi of 2 is equal to 1, phi of 3 is equal to 2, and what, phi of 5 is equal to 4, phi of 7 is equal to 6, phi of 11 is equal to 10, and phi of 13 is equal to 12. And while phi of 2 plus 1 equal to what, phi of, okay sorry, यहाँ पे क्या है आपका, p क्या ले लेना, greater than 2 ले लेना, then greater than 2 ले लेना, then this thing will be true, okay, here where your p is greater than 2, okay. So यहाँ पे क्या आ जाएगा आपका, क्या आ जाएगा, 5 plus 1 which is 6, and phi of what, phi of and it could and so on, so here infinitely many terms. So यहाँ पे क्या हो जाएगा आपका 7 plus 1 which will be 8, and you can see this it's simply phi of 12 plus 1 and phi of 13 plus 1 and dash and so on, okay. So see here what you will get, phi it will be 2, and here phi 6 की वैल्यू क्या आ जाएगा, 2 आ जाएगा, phi 8 की वैल्यू क्या आ जाएगा, see phi of 8 means कि 2 की पावर 3 which is nothing but 2 की पावर 3 minus 2 की पावर 2 which is equal to 4, okay. एंड यहाँ पे phi 12 क्या आ जाएगा, एंड 4 आ जाएगा, एंड 540 क्या आ जाएगा, 540 क्या हो जाएगा, phi 2 into phi 7, okay, which will be 6. So as you can see, and it is and so on, so and you can see here phi of n always is strictly greater than phi of n plus 1. Now for option okay, so our option first is correct, okay. Similarly you can do easily for option second, so it is also correct. And for what, okay, here there exists in option 3 there exists a natural number n such that n is greater than 2. अच्छा, n की वैल्यू greater than 2 है, and for all n is greater than capital N, phi of capital N is less than phi of n. अच्छा, okay. See what we will take here, think about, okay. So what we will take, okay, as we know phi of 3 is equal to 2, phi of 4 is equal to, is it good way, phi of 5 is equal to 4, phi of 6 is equal to again 2, phi of 7 is equal to 6, phi of, okay, see if we take what, if we take also I think it is a in general it is true, if we take a n equal to what, 6, if we take n is equal to 6 and n, your n is greater than n small n, स्मॉल एन क्या ले लो आप, क्या ले लो, 6 से बड़ा ले लो, ठीक है, 6 से बड़ा ले लो, 7 8 9 10 वट एवर यू विल चूज, वट यू विल गेट ऑलवेज जो phi ऑफ n आएगा वो हमेशा क्या ग्रेटर देन इक्वल टू 4 आएगा, ठीक है. फॉर ऑल n ग्रेटर देन 6 check whether it is true or not. According to me it is correct, okay. So ऑप्शन 4. अच्छा, यहाँ पे हमें फाइंड आउट क्या करना था, कौन सा गलत है. तो फर्स्ट करेक्ट हो गया, सेकंड भी करेक्ट हो गया, थर्ड भी करेक्ट हो गया. C4 द सेट phi of n by n, okay. So the set phi of n by n such that n natural number has a finitely many limit point. As we know, what we know, as we know 4 6 8 there are okay 4 6 8 and there are 4 6 8 and 10 12. These elements in repeats infinitely many time, which means यहाँ पे आपको क्या मिल जाएगा, okay 1/4 आई मीन इसकी लिमिट पॉइंट्स फाइव ऑफ एन की इनफाइनाइटली मेनी आ जाएंगे, क्योंकि यहाँ पे इनफाइनाइटली मेनी टाइम्स 4 रिपीट करेगा, 6 रिपीट करेगा, 8 रिपीट करेगा. सो हाउ कैन वी से इट इज़ फाइनाइट, है ना. सो वहाँ से आपको क्या मिल जाएगा, 1/4 एंड what I think it is not correct, but we have to verify. Okay, so how to do? Okay, how to do this in general way? Okay, so we will do this option 4, but it is correct, and it has infinitely many limit point. Okay, as you know these terms repeat infinitely many times. So here 1/4 and 1/4, 1/5, 1/7, and another are also terms are repeat infinitely many times, and that is why it has infinitely many limit point. Okay, so do your own again this option 4, because I am not getting in the correct way. So but according to me it is incorrect. Okay, as you can see here, infinitely many terms are repeat. So try this question and let me know how you will do this question. Okay, so it is question number 13, and it is from number 30 question. Okay, so let us try to do another question, and it is again abstract algebra question. Now it is abstract algebra question. Okay, so what is our question? It is question number 17, and what is question? Let x be a non-empty set and p of x be the set of all subset of x on p of x, and define two operations star and l as follows for a comma b in p of x, and a star of b is equal to a intersection b, and a till b is equal to a union b minus a intersection b. Okay, so solve it as a star is not a group. As you can see here, the inverse element only for phi and what phi and only phi का इनवर्स एग्जिस्ट करेगा यहाँ पे. ठीक है, phi का और किसका एग्जिस्ट करेगा, x का एग्जिस्ट करेगा, अदरवाइज किसी का एग्जिस्ट नहीं करेगा. एज यू कैन सी phi intersection whatever you choose, you will get phi, and phi of phi and x intersection a, you will get a. Okay, you will not get phi na. Okay, आइडेंटिटी भी एग्जिस्ट नहीं करेगा, इसका एग्जिस्ट करेगा आइडेंटिटी. एक्स क्या करेगा, आइडेंटिटी का काम करेगा. यस, आइडेंटिटी एग्जिस्ट करेगी. ठीक है, एज यू नो एक्स इंटरसेक्शन है वट एवर फॉर ऑल ए इन पी ऑफ एक्स. ओके, so for all p of x you will get what a. so identity तो exist करेगा but inverse exist नहीं करेगा. okay, different a के लिए different I mean as you see a intersection x, okay, not equal to identity ना phi. so phi only possible if you take a intersection phi ना, or a intersection or nothing you can take here na. Okay, so I think existence of inverse fail here, so that is why it is not correct. Star group नहीं form करेगा. and see what about del. okay, verify it until आपका क्या करेगा, फॉर्म करेगा. एंड चेक फर्स्ट चेक क्लोजर प्रॉपर्टी, देन सेकंड चेक एसोसिएटिविटी, एंड थर्ड चेक एग्जिस्टेंस ऑफ इनवर्स. then check fourth existence of identity, and fifth check, because here we are just checking the group, so not abelian group, but you can just see whether it is with the commutative or not. Okay, so check this also, because I don't want to make it a too long video, and that is why I am skipping it, and it is easy, you can just verify it. And what you will get here, and as you can observe, it always closure property, because when you take see union of two sets is again set which is again belong in your P of X, and intersection again in your X. And when you subtract something from if you take A minus B again in your in general again in your P of X. Okay, either these are containing each other or not. If you not contain, then again it here. If not, if distinct, again it here. So yeah. In general it is again in, so it is closure. Associative also hold. We will just use the property of intersection and union, so we will get this also. So try to see what is inverse and what is inverse. So inverse element. Okay, see, if you take in general A intersection A del A, so what you will get A union A, which is again A, and minus A intersection A, which is again A, so you will get phi. And why it is phi? Because it is A and minus A, so phi. So as you can see, it is true in general. So for all A in P of X, so your so existence of inverse hold, so it is also correct. And existence of identity, what will be identity here? What will be identity? I mean, what you will take here. So here no effect. So what about X? Can we take? Okay. A union phi minus A minus A intersection phi. So A intersection phi is again phi, right? And it is A, because A union phi is equal to A. Now you will remove phi in there, no effect. So it is for all, it is true for all A in P of X. So it general. So here your existence, your identity क्या हो जाएगी? Phi हो जाएगी. So यहाँ पे it self inverse होंगे element. I mean self inverse होंगे. I mean each element का order क्या हो जाएगा? 2 हो जाएगा, as you can see from here. And यहाँ पे identity क्या आ जाएगी? आपकी phi आ जाएगी, ठीक है? Okay. So यहाँ पे identity phi आ जाएगी, and each element self inverse हो जाएगा. Okay, so let us try to solve question number 18. What is our question number 18? So let us read our questions and then try to solve it. So what is our question number 18? Which of the following statement is true? तो हमें बताना है इनमें से कौन सा करेक्ट है. अच्छा, so first of all given क्या है? Okay, so क्या दिया हुआ है? Let me see what is given here. So as you can see, what is given? Option number A. So first option क्या है? For every, so every even integer n जो कि n greater than equal to 16 है. अच्छा, ओके, सी n क्या है? greater than equal to 6 है, क्या है? इवन है, ठीक है, इवन है. अगर n इवन है, सी इन जनरल इफ n इवन है तो n प्लस 1 क्या हो जाएगा? ऑड हो जाएगा ना. अच्छा, अगर ये ऑड हो जाएगा, और आल्सो सी इफ n इवन देन n minus 1 ऑड. ओके, एंड ऑड प्लस ऑड. अच्छा, सी इट इज फैक्टोरियल ना. सो n minus factorial, and it is here n is greater than 60 for every n greater than equal to 60. Okay, so n minus 1 factorial plus 3 na. Okay, so it is even and it is odd, and as you can see your n is what? Your n is even na, but your this thing is odd, so it will not divide na, because even does not divide odd. So your option A is incorrect, right? Okay, now every odd integer, similarly you can do this option, it is also incorrect. How it is incorrect? Similarly as I done similarly as option first, you can just try to solve option second, and it's same. That is why I'm not doing this. If you want, I can do. Let us do. Okay, so suppose what? Suppose n odd. Okay, if it is odd, then and what? It is greater than equal to 60 and it is odd. So what can you say about n minus 1 factorial? So first of all, it will be what? Even. Okay, so it will be even, and see, it is even and it is odd, so it not divide now. Wait a minute, let me think again. Okay, can we take 70? See, 70, is it divide your 16 factorial? No, it does not. So it is not true. So your option second is also not correct. Now see option 4. Okay, so option 4 क्या दिया हुआ है आपका? ऑप्शन 4 क्या दिया है कि एवरी इंटीजर, अच्छा एवरी इंटीजर जनरल इंटीजर है, ठीक है, एवरी इंटीजर वॉट एवर यू आर इंटीजर टेकिंग विद हियर इट डज नॉट मैटर. सो टेक अगेन 17. सो 17 का स्क्वायर होगा, इज इट डिवाइड योर 17 फैक्टोरियल इंटू +1? सी इट, इज इट डिवाइड? ओके, व्हाट यू विल गेट? कैन वी सी एनीथिंग? सी इट इज इवन ना, it is even, and only 117 is present here. Okay, let me think again. What can we say? Okay, what about if we take 60? If we take, because every integer we can take na, every integer we can take. So if we take 16 का स्क्वायर and then factorial 16 factorial +1, अच्छा, then it will be odd now, so it will not divide. So that is why option 4 is also not correct. Okay, so it is also not correct, and so remaining option your third, so option third will be correct, and you can just verify it. So these 3 are incorrect. Okay, if you are doing this question in another way, so let me know in a comment box. Okay, so let us try to do another question. Okay, and I think we've done all part B question. So see you soon in the next video, where we will solve 2020 16 number, and it is algebra question, means abstract plus linear, and we will try to solve a part C question. A little bit difficult. I think part B it will be little bit lengthy also. So see you soon, we will meet again. Bye bye, take care.